In this section, we are going to discuss a very important concept called RAG, which stands for Retrieval Augmented Generation. Before we start coding, it's important to understand what RAG is, why we need RAG, and how it actually works. We mainly use RAG for two situations. First, when the LLM does not know the latest information. For example, if the model was trained long ago and the user asks about something new or updated, the model cannot answer correctly because it has no recent data. Second, when we want the model to answer using our own data, like company documents, user manual, PDFs, policies, resumes, internal records, research notes, etc. The model was never trained on this private data, so it cannot respond using it, right? So in both of these situations, we need a way to supply the relevant data to the LLM at the time of questioning. But please remember, we cannot dump huge documents or entire databases into every prompt. That would be slow, costly, and inefficient, right? This is exactly where RAG becomes powerful. Let's discuss how RAG solves these problems. So RAG helps the LLM by pulling only the useful part of the data instead of everything. So here is what happens inside RAG. We take our data. It could be documents, PDFs, reports, or internal company content, or even user manual, anything. We break it down into chunks. After that, we generate embeddings for every chunk and store them in a vector store. Later, when user enters a query, we convert that query into an embedding as well. After that, we search the vector store to retrieve only the chunks related to that query entered by a user. These selected chunks are added to the prompt and sent to the LLM as context for that query. So the LLM can read the question, means query asked by the user, and the related information together. Now the LLM has the user question, means user query, plus the correct data as context, only related data with that query that we retrieve from the vector store. So it produces a much more accurate answer, which is given back to the user. In simple words, we can say RAG retrieves the right information, adds it to the prompt as a context, send it to the LLM, and the LLM gives a better response. As simple as that, right? The question is why this matters. So please remember, if you consider the scenario without RAG, the LLM mostly guesses based on what it was trained on. With RAG, the LLM answers using real, up-to-date, and the relevant data. This is how, using RAG, we allow LLM to answer from our personal knowledge base, company internal files, user manual, or updated information. Hope all of you are clear with how RAG works. Please remember, the best part is LangChain makes this entire process easy to implement. So in the next step, we are going to build RAG from scratch using LangChain. Now, first of all, let's create one new Python file, rag1.py. So now the question is what we are going to build. We are going to build a Wi-Fi router support system. So assume this document that I have created that you can take from my GitHub account. Link is provided in the description of this video. You can see it contains the following information about the router. This is our router. Introduction about the router. Package contents. Hardware overview about the router. Powering on the router. You can see internet connection setup for this router. Wireless network details. Logging into the router. You can see, right? With the IP address as well, with default username and password. Also, it contains information about changing Wi-Fi name and password. Also, security features about this particular router. You can see also information regarding resetting the router and troubleshooting steps that you can see. Also, at the end, it contains technical specifications and support. Great, right? This is our user manual for the router. Now, we have all this information about the router. So if a user has any problem or query, instead of reading this entire manual, the system can search this document and provide the relevant answer to the user. This is exactly where RAG fits in. The system does not need to know everything about the routers in general. It only needs to understand and use this specific manual only. So RAG allows the system to first look up the correct section of the document and then generate a response based only on that information, nothing else, right? So without RAG, a model might give general networking advice or assume some features that are not mentioned in this particular manual. With RAG, the system behaves like a support agent who checks the manual before answering. This makes the responses accurate, reliable, and directly aligned with what the router actually supports, right? So we are going to implement this Wi-Fi router support system using RAG. So let's get started. So first of all, let's import all the required libraries, and we will discuss all these libraries in detail while coding. So from LangChain underscore community dot document loaders, let's import text loader. From LangChain underscore text underscore splitters, we have to import recursive character text splitter. From LangChain underscore OpenAI, let's import OpenAI embeddings class. From LangChain underscore community dot vector stores, we are going to use Fias. From Facebook, you can use Chroma as well or any other vector database. Now from .env, let's import load underscore .env. From LangChain underscore core dot prompts, we are going to use chat prompt template class. From LangChain underscore OpenAI, let's import chat OpenAI class. So next, from LangChain underscore classic dot chains dot retrieval, we have to import create underscore retrieval underscore chain. Also from LangChain underscore classic dot chains dot combine underscore documents, we have to import create underscore stuff underscore documents underscore chain. As you can see, we are using LangChain version V1, and with this newer version, a few things have been reorganized. Some of the older chain logic has been moved out into a separate package that you can see here. So to keep everything working smoothly, we need to install this package. Pip install LangChain underscore classic. Actually, I have already installed, right? You have to install in your case if it is not already installed. Done. Let's save this. Once that's done, the rest of the RAG pipeline works without any issues. As you can see, now we have imported required libraries. Now let's move on. First, let's load our environment variables. Just to read the API keys from the .env file using load underscore .env that we have already imported, that you can see. Next, we are going to load the document, this particular document, right? Wi-Fi router user manual. For that, we have to use text loader, and here we have to use this file name Wi-Fi underscore router underscore user underscore manual dot txt. Let's assign it to one variable. Loader is equal to this, and loader dot load, let's assign this to docs. Done. So here we are loading our Wi-Fi router user manual. At this time, our document will be loaded as one big block of text. Larger text is hard to work with, right? So the next step is to break it into smaller pieces called chunks. For that, we are going to use recursive character text splitter. Let's define here chunk size is equal to 1000 characters. Chunk underscore overlap is equal to 200. Let's assign it to one variable splitter. Next, splitter dot split documents, and here we have to pass our document, our Wi-Fi router user manual. Let's assign it to one variable chunks. Done. So here each chunk is about 1000 characters long, because here we have set chunk size to 1000. And here we are defining chunk underscore overlap is equal to 200. This overlap ensures that no important information is lost between chunks, right? That's why here we are doing overlap of 200 characters. Now let's move on. Let's convert these chunks into embeddings. As you know, embeddings are just numerical representation of the text that help the system understand meaning, not just exact words. Here we are using OpenAI embeddings that we have already imported, right? Let's assign it to one variable emb. Along with these embeddings, we also need a chat model that will generate the final answer. For that, again, we are using chat OpenAI. Let's use model GPT-40 mini and let's assign it to one variable LLM. Done. Next, we have to store all the embedded chunks inside a vector store. So here we are going to use Fias. You can use Chroma as well, right? So Fias dot from documents. Here we have to pass chunks and our embedding model. Let's assign it to one variable vector underscore store. Done. So now let's use retriever. So vector store dot as underscore retriever. Let's assign it to one variable retriever. You can use any other variable name as well. So now return this vector store into retriever. So the retriever's job is simple. When a question comes in from the user, it finds the most relevant parts of the document, right? Let's move on. Now, before answering the user question, we need to tell the LLM how it should behave. And this is done using our chat prompt template class that we have to define, right? Next, chat prompt template class. And here, system message. Let's write in triple quotes. You are an assistant for answering the questions. Use the provided context to respond. If the answer is not clear, acknowledge that you don't know and limit your response to 2 concise sentences. Done. And here the main part, we have to define context. Done. This is our system message. Next, we have to define user message, which is called as human message, and that we will receive as an input from the user. Done. This inside list. Done. Right? Stop tuples. You can see here we are clearly telling use only the given document. If the answer is not present, say you don't know and keep the answer short. Right? Let's assign it to one variable chat prompt is equal to this. Done. Please remember this context is very important. Is the place where the document content is inserted. When a user asks a question, LangChain automatically fills this context with the most relevant chunks retrieved from Fias, our vector database, right? So this is how the model actually reads the document before answering through this context. So without context, the model would only see the question and might guesses the answer. With this context, the model is forced to answer from our document only, from our Wi-Fi router user manual only, right? Done. Next part is very important. Now comes the QA chain. For that, we have to write create underscore stuff underscore documents underscore chain. Let me define first, then we will discuss, right? Here we have to pass LLM and our chat prompt template, this one. Let's assign it to one variable QA underscore chain is equal to this. Next, we have to create a rack chain. For that, we have to use create underscore retrieval underscore chain. Here we have to pass our retriever. Let's change the spelling, retriever, and also here we have to pass our created QA chain. Assign it to one variable rag chain, right? And here we have created 2 chains, QA chain and rag chain. So please try to understand logic behind this. First, this rag chain. This rag chain does the searching. When a user asks a question, it goes to the vector store, in our case Fias, and finds the most relevant parts of the router manual. It simply figures out which part of the document talks about the question asked by the user. After that comes this QA chain. This QA chain takes those selected parts and puts, means stuff them into the special place in the prompt called context. Here, this context tells the model, read this before you answer, right? So the model reads the context and answer the question, not guessing. So the models, our LLM reads this context, which is stuffed by QA chain, and the answers the question. No guessing, only document-based answers. Hope all of you are clear with this, right? Our two chain, LangChain, which retrieve relevant parts from the document, and our stuff chain will stuff that retrieved part as a context inside our chat prompt template, right? And this context tells the model, read this before you answer. Hope all of you are clear with this, right? Working of QA chain and LangChain. Now finally, we make the program interactive. Let's do this. Now let's print chat with router manual. Let's take input from the user, your question. Assign it to one variable. Question is equal to this. Now if the question is entered by the user, then invoke this LangChain. Here we have to pass this dictionary input and this question, right? And let's print. For that we have to store inside some variable, right? Response. Let's print response and answer part of this response. Done. So in simple terms, the program works like this. First, we load a document. After that, we are breaking it into chunks, store them inside our vector database, search the right pieces or chunks of the document, and answer the question using only that document. As simple as that, right? So for that, we have implemented these two chains, QA chain and LangChain. Let me explain you one more time. So first, this LangChain does the searching. When a user asks a question, it goes to the vector store and finds the most relevant parts of the router manual, means from our document. It simply figures out which part of the document talks about the question asked by the user. After that, the QA chain takes those selected parts and puts, means stuff them into a special place in the prompt called context. Here we have to use the context as it is, like this only, right? This context tells the model, read this before you answer. Please remember, we have to use context exactly like this, as I just said, right? So that LangChain knows exactly where to insert the document text. Then the entire prompt is sent to the model, this model, right? The model, means our LLM, reads the context and answer the question. No guessing, only document-based answers. This way RAG works, right? Let's open new terminal. Let's clear this. Let's run our code. Rag1.py. So let's ask our question. What is the default IP address to access the router setting? And great, you can see the default IP address to access the router settings is 192.168.1.1. You can see this answer is coming from our document. It is not guessing, right? It is not from the general training. It is from our manual only, this only, right? And you can see here as well, this one, right? Let's clear this. Let's ask one more question. And you can see here, the question was, which encryption standards does the router use? WPA2 and WPA3. And it is coming from our document only. You can see, great, right? So this way RAG works. But please remember, our current RAG is not aware of conversation history. It is not maintaining past questions and answers. It treats every query as a new request. Next, we are going to discuss history-aware RAG, where the system remembers earlier interactions and can respond better to follow-up questions. Hope all of you are clear with this, right? How RAG works with LangChain. Let's move on.